The new topic for today is definite integral under U substitution. And I want to show you two methods to solve one question, and only the second one will be the preferred one. Not that I will take points off if you do it the first method. It does give you correct answer, so I can't take points off, but I really want you to do it the second method, and I'll explain the reason why later, okay? So here's an example. Let's say you're trying to integrate x plus 1 over, say, x squared plus 2x minus 1 dx. And let's say we're trying to integrate from 1 to 2. How do we integrate? Well, let me show you two methods. Method 1. Method 1 just says, well, we'll worry about the definite integrals, worry about the bounds later. We'll just do the indefinite integrals first, because that's what we are used to doing, right? So just do this one. Okay, question. What should I set my u equal to? Yes? That's a reason, one of the reasonable choice, right? Okay. But unfortunately, it's not going to work. Okay. The bottom one, the entire bottom one will be your choice. Yeah, actually, if you differentiate the bottom, you get 2x plus 2, which is just double of this one, right? So it's almost like f prime over f type. That has antiderivative as the element. So let me say something like that. If you have ln of a function, and if you differentiate, what do you get?
1 over
F prime of x over f of x, right? Yeah, you're right. If you differentiate ln of x, it's 1 over x. So if you differentiate ln of f of x, it'll be 1 over f of x. But then the chain rule says you have to bring the fx out and differentiate. That's why this top one appears, right? And what that means is that the corresponding integration statement is if you integrate f prime of x over f of x dx, the end result is ln of absolute value of f of x plus c, where this absolute value appears of something that I explained yesterday, right? Okay. So actually, there's a way to quickly do this without even doing the u substitution, which is to say, well, put a 1/2 in front and put a 2 there, and the antiderivative is just because it's f prime over f type, it's just ln of the denominator with 1/2 in front. Okay. Since I'm going to solve this twice, in the second time around, I'll just do it that way. But right now, let's do the u substitution, the full u substitution. U equals to x squared plus 2x minus 1, and du is equal to what?
2x plus 2.
2x. You first find the derivative, and then what do? You attach dx, right? And then you solve for dx by dividing by this thing in front. Du. Right? And now you have everything that's required. Let me write it over here. So that integral right here will be equal to, no, not this one, this one here. This one will be integral of x plus 1. We decide to call the entire bottom as u. And it's 1 over 2x plus 2 du. Dx changes to, this much changes into, no, keep referring to this one. This much changes into this one, right? So I replace this by this, and that's the end result. Now, we're not done with the u substitution yet because I still see x's. Okay? You have to get rid of them before we can do further. Yeah, what do we do?
Once you rip out the 1/2.
Right. So you see that you can factor the 2 out, right? Yeah. And if you do that, the x plus 1's cancel out. So this just simply becomes 1/2 integral of 1 over u du. What's the antiderivative of 1 over u? ln of u with the absolute value, right? And this is 1/2 ln of the denominator, which is x squared plus 2x minus 1 plus c. Okay, so once you do that, now we have to calculate this using the fundamental theorem of calculus, right? Which says you have to find the antiderivative, which we already did, and plug in the endpoints. That's the fundamental theorem of calculus. So you write down the antiderivative of this, which is 1/2 ln of x squared plus 2x minus 1. And please don't put plus c on definite integrals, okay? It's just, the fundamental theorem of calculus says just take any one of the antiderivatives. So we're going to take the simplest one where c is equal to 0, okay? And then we plug in the endpoints 2 and 1. Now this symbol here, this bar with 2 and 1 means you put the 2 in. So what is that? That's 1/2 ln of 2 squared plus 2 times 2 minus 1 minus, and you put the 1 in. So 1/2 ln of 1 squared plus 2 times 1 minus 1. So that this is 1/2 ln of, let's see, 4 plus 4 minus 1 is ln of 7 minus 1/2 ln of 3 minus 1, that's 2. So that'll be the answer, or if you want to simplify a little bit, I'm not so sure if this is anything simpler than the other, but if you subtract 2 logs, that's same as division, right? So you can factor the 1/2 out, and then it's ln of 7 minus ln of 2, that's same as ln of 7 over 2. Maybe it does look simple. But this will be full credit if you stopped here in the exam, okay? All right, so that's how you do it in the first method. Now compare this with the second method. You know what? Let me. Yeah. So I'll just have to. I'll have to delete everything. Okay. So method 2, the method that I want you to try out or stick to is you set u as the denominator, so that the denominator is u, and then, so I'm going to skip the part which I did before. It was that du is twice of this thing, right? So du is equal to twice of x plus 1 dx. That's what we had before. So what I can do is I can make the 2 appear by dividing by 2 in front. So if I give you a present and I immediately take it back, what happened? Nothing happened, right? It's like this. I put a 2 there, I immediately took it back, so nothing happened. That's the idea, right? Okay, and I like this one because now this is what? This is du. So I still have 1 and 2, so I want this to be du. But there's one more thing that we do. I should raise that. There's one more thing we do, which is, actually I want to write this in another color because this is important. When x is 1, u is, since u is x squared plus 2x minus 1, it's going to be 1 squared plus 2 times 1 minus 1, which is 3 minus 1, that's equal to 2. Okay? When x is equal to 2, u is equal to 2 squared plus 2 times 2 minus 1, which is 7. And then we say the integral, this integral right here, this is same as 1/2. As I said, this is same as du, right? So it's 1 over u du. And I write the values calculated here. So 2 and 7 goes here. So that's what happens to definite integrals. So in other words, when doing u subs to definite integrals, change the bounds as well. Okay. That's my point. You have to change the bounds when you directly apply u substitution to a definite integral. So in the first method, we didn't have to do that because we were just doing the indefinite integral. And indefinite integrals don't have any bounds, so you just do it the old way, and we just applied the fundamental theorem calculus. Right? But here, I not only transform the x's into u's accordingly, but the bounds also have to be transformed into the new bounds because u have a different value. All right, so what's really happening is this. Over here, what are the nature of 1 and 2? These are the values of x. X goes from 1 to 2. And you draw this graph and you look at the area under the graph. That's the meaning of this definite integral, right? Over here, what's happening? It's du. So what should these values be? Should be the values of u. That's why you put 2 and 7. If you write 1 and 2, that's wrong. Okay? You have to write it this way. That's the proper way. Yes?
I get what you mean by that, but like in the beginning when you took it the 1/2 outside of it, right?
Mm-hmm.
This kind of like that part, the 1/2 and then the 2.
Oh, okay. So you were asking me why I did this. Well, I was trying to take a shortcut. I could have done it exactly following method 1 for that part. It doesn't matter. I just wanted to point out that if you differentiate this, what do you get? It's 2x plus 2, right? And if you factor the 2 out, you get this. And I'm saying, well, I wish there was a 2 there because then I can just say it's du. But I'm lacking a 2. So you wish for something, and how do you get it? By putting something that would cancel it. So equal signs cannot work if you just put things that you want it to be there. That's no good, right? However, it can still be made to work if you cancel it.
So you cancel the 2.
Yeah, I put a 2 and I canceled it. And it's still the same as this one, right?
Yeah.
You agree that these two are still the same, right? Yeah. Yes?
So if you needed like a 3 or a 4, you just do 1/3.
Yeah, if I say I really want a 4, put a 4 and put a 1/4, done. Yeah.
And then that became 1 at the end?
Huh?
Then the x plus 1 became 1 at
No. 2x plus 1 times dx is same as du, right? So that much is this du.
the end? Okay.
You see what happened? Yeah. This much is equal to du.
Okay.
So that's how you got rid of x without having to. Okay.
Oh, yeah. I mean, if you don't like what I did here, you can also do it the other way that we did. So what was that? It was du equals to 2x plus 2 dx, right? And then dx is equal to 1 over 2x plus 2 du. And that integral will be 2 to 7 of x plus 1 over u times 1 over 2x plus 2 du.
So it's the same thing.
And then, yeah, and then these two will cancel and the 1/2 will come outside.
It's the same thing.
Yeah, it's the same, exact same thing. You get this exact same thing. I just tried to skip a step, and that's what made you more confused. Sorry about that. But it's good to play with this algebra because you get better at algebra if you do this. All right, so where are we at now? What's the antiderivative of 1 over u? ln of u. And then you plug in 7 and e2. Now the beauty of this is that, look, 7 and 2 are values of u. So they go in here. And so it's 1/2 of ln of 7 minus 1/2 of ln of 2. Exactly what we got before. So you get the same answer. Both gives you the same thing. But I'm just saying that this is the proper way to transform a definite integral, and it's often the shorter one. Okay? You get a shorter solution. Now, some people do not know that they have to change the bounds, and they would do something like this. But I want to write the correct one. So here's method 3. Oh, but don't write method 3 because I really don't want you to do method 3. So everything the same, but you would do something like this: 1/2, and they are really stubborn. They say, oh, I still want 1 and 2. But for that to be correct, now this would be wrong, but you can still make this correct. The correct way to write this is to say x equals to 1 and x equals to 2. Then it's not wrong because you're still saying, oh, these are values of x, not u. If you don't have these, it's wrong because then it means without having x equals, it means the value of u, which is not true. Okay? So you can do this, and then you would do 1/2 ln of u, x equals to 2, x equals to 1. And this time, these cannot go in here because these are the values of x. So you have to go back to 1/2 of ln of x squared plus 2x minus 1, right? And then you plug in 2 and 1. Now you can plug these in because these are the values of x, which will give you the final answer, right? And all 3 ways, if you do it on the exam, I will be giving you full credit because they're all correct. Except the preferred method is this second one. Why? That's because, here in this school, most of you are engineers, and you have to take multivariable calculus, right? In multivariable calculus, you do double integrals, where you don't just integrate by x, but you also integrate in y. So you integrate by x first and then y. And when you do change of variables in double integrals and afterwards, it often becomes very crucial that you change the bounds along with the change of variables. Okay? And so I'm trying to make you do the correct method here so that it's going to help you out in multivariable calculus. Okay? So don't be stubborn. Don't do it this way. I'll be mad. Yeah, I'll look for any small mistake and take points off. Okay? If you do it this way. Okay? Try to do it this way. Then I'll grade more lenient.